Alright, let's begin the exciting topic about collagen. Everything you need to know about collagen, ranging from the types of collagen to the synthesis, and then we'll cover a few collagen disorders at the very end. So let's talk about the different types of collagen. You've got 1, 2, 3, and 4. Those are the 4 main subtypes of collagen. Type 1 collagen is going to be found in your bones, in your tendons, in your ligaments, and then in your dentin, which would be like in your teeth, the collagen that's in your teeth, and in a few other locations. These are the main ones I want to cover. And then we've got type 2 collagen, which is going to be in your cartilage. And then also, you'd see it in your nucleus pulposus. The nucleus pulposus is going to be in your vertebral discs. The intervertebral discs is going to be the central portion. The outer portion of those discs are going to be the annulus fibrosus, but the middle portion is going to be the nucleus middle pulposus. Pulposus. Think nucleus kind of like the middle of the cell. Nucleus is in the middle of the cell. The nucleus pulposus will be the middle of the intervertebral disc. Type 3 you're going to see in the skin primarily. And then type 4 would be more basement membranes. And so it is important to cover these different types because we'll see different disorders. Alport's disease, for example, will involve type 4 collagen specifically. Other ones will involve type 3 and type 1. It's important to realize where you see each of these different types. So we just covered the different types. Now let's go into the high yield subject of synthesis. Let me find a marker. That'll do. The synthesis. Synthesis of collagen is going to be made by fibroblasts. Fibroblasts are going to make collagen. The usable form of collagen is going to be in a triple helical unit made up of 3 alpha chain collagens. We'll cover all that, but right now I want to focus. Your DNA is going to be in your nucleus, and your DNA is going to be transcription, going to be translated into mRNA. That mRNA is going to be translated into an actual protein. And that protein is going to be what our collagen subunits are going to be made out of. Those pre-pro collagen units will eventually be transformed into collagen. So here is our synthesis. We're going to begin, so we'll go from the nucleus, which has our DNA. That'll get converted into mRNA. That mRNA is going to go to our rough endoplasmic reticulum, which hopefully you know by now that your endoplasmic reticulum are going to make your proteins. Collagen is a protein. Collagen is actually going to be the most abundant protein in the body. That's good to know. So we go from the nucleus, make some mRNA. That mRNA is going to encode for our collagen stuff. The rough endoplasmic reticulum reads that mRNA. Eventually we'll go to the Golgi, have a little fun in the Golgi, and then we'll leave the cell. So extracellular. We all know that collagen gets secreted by fibroblasts into the extracellular matrix, and that is its end destination. So this is kind of our roadmap of where we're going. So we just made our mRNA. That mRNA migrates to the rough endoplasmic reticulum, and that's where our journey first begins. So let's take a look here. When our mRNA gets translated, it's going to be in a form called pre-pro collagen. A double prefix here. Suffix would be at the end. All right, so pre-pro collagen, and that's going to be made up of repeating units of gly-x-y. Well, what does that mean? We have a glycine, an X subunit, and a Y subunit. Glycine XY, glycine XY, glycine XY. You're just going to have repeats of this, and that's all what this means. So what is this X and the Y? Well, the X is typically proline. So proline is just going to be an amino acid. Glycine's just an amino acid. And then Y is going to be mostly lysine, which is yet another amino acid. Glycine, X, Y. And we write it like this because the X can be other stuff, the Y can be other stuff for the most part. For the most part. Mostly X's are proline. For the most part, the Y's are lysine. Alright, so where do we go from here? Well, we're still in the rough endoplasmic reticulum, so let me get a blue. We're still in the RER, but we'll be migrating. So we have the mRNA that's translated into pre-pro collagen. What modifications can we make from here? How are we actually going to change this pre-pro into actual collagen? What we're going to be doing is we're going to be doing a process called hydroxylation. Hydroxylation. And we've got an excellent clinical correlation to this step. So what we're looking at is we put an OH. Hydroxylation is simply an OH group, an oxygen and a hydrogen. And we're going to attach this to the proline or the lysine residue. So we're going to put OH onto proline / lysine residues. Alright, what happens if this goes wrong? This step, this hydroxylation, requires vitamin C. Now vitamin C, if you've watched my vitamin videos, there's an awesome, actually it's my favorite disease that's associated with a deficiency in vitamin C. So if you're a vitamin C deficiency, you have scurvy. Scurvy. It's what the pirates used to get because there was not enough fruits and vegetables on the ships on those long voyages. They'd have a vitamin C deficiency, they'd get scurvy. So they would actually have a collagen disorder. And let's think about it. They would have a collagen disorder. Collagen is found everywhere there. It's also found in blood vessels. It's found in the skin. It's found in bones, tendons, ligaments. They'd get bleeding gums. They would get bleeding gums because they cannot synthesize collagen correctly. So their blood vessels would be weak. They'd get bleeding gums. They'd get ulcerations on their leg. But this is where you get scurvy. So the hydroxylation step, it occurs in the rough endoplasmic reticulum. All right. So let me get the colors out again. There's another step that's also going to be found in the rough endoplasmic reticulum. And so this step is going to be called glycosylation. Glycosylation. What is glycosylation? Let me write this. Glycosylation. All right. What is glycosylation? It's where you add a carbohydrate onto, in this case, the collagen. So add carbohydrate. So glycosylation, this is going to be the next step. And this is where we convert it from pre-pro collagen into simply just pro collagen. We'll get out of the way here, collagen. All right, so now we went from pre-pro collagen, so a double prefix, to now just a single prefix. So we're getting more mature. We're maturing that collagen. I'm not even sure if that's how to spell. All right, so what are we looking at? We are looking at creating hydrogen bonds and disulfide bonds at this step. So we added some hydroxyl groups to the proline and the lysine. Now that I look at this, let me just... All right. Sorry, a little brain freeze there. I've been looking at collagen all this time. Every time I write collagen, it looks like I spell it wrong. That's how it's spelled. And I know that's how it's spelled, but every time I look at it, it just looks wrong. All right, that aside. So, collagen. At this step, in the glycosylation step, we just added a carbohydrate. From here, what we're going to do is the collagen is going to create hydrogen bonds. And it's also going to create disulfide. So if you have two sulfurs together, it'll create a bond between them. That's a disulfide bond. So we're creating hydrogen bonds. So I'm going to write it H bond. And disulfide bonds within that collagen helix. All right, so what are we looking at? We're looking at disulfide bonds, hydrogen bonds, and that's going to form a triple helix. So 3 alpha chain collagen units, collagen, that is how you spell it, form a triple helical unit. All right, so 3 alpha collagen chains are going to H bond with each other, disulfide bond, and create a triple helical unit. All right, so we went from pre-pro collagen, we added a hydroxyl group, glycosyl group. It's now called pro-collagen. That pro-collagen is going to bond, or is going to hydrogen bond and disulfide bond with 2 other units, creating a triple helical unit made up of 3 alpha chains of collagen into a triple helical unit. There is a disorder with this, but I'm going to continue on with the pathway here. Next, we're going to move on to the Golgi. So let me find my... So I know we're kind of running out of room. It is a complex pathway. So now we're in the Golgi apparatus. What does the Golgi's function do in the cell? Well, we know that the Golgi is kind of like the postmaster. It assigns proteins to various portions of the body, and it can also assign collagen to the outside of the cell. So it's going to secrete the collagen extracellularly. So secrete into extracellular matrix. So up here we went from nucleus, mRNA. Now we're in the extracellular. The Golgi sends this pro-collagen into the extracellular matrix. Extracell. And to do that, it's going to use the there's a cis and there's a trans phase. It's going to use the trans Golgi network to do so. All right, so we went from the rough endoplasmic reticulum to the Golgi apparatus, and now we're outside the cell. So let's move down. Out. Out stands for outside the cell. And once we're outside the cell, it is now called tropocollagen. So I'll get out of the way in just a second. Tropocollagen. Tropocollagen. So what this is we're going to cleave the ends of this pro-collagen. So we're going to cleave, actually I can make this a little graphic. Pro-collagen to tropocollagen. So what we're going to do is we're going to cleave off some of the end units of this collagen. Let's say this is a long molecule of pro-collagen. We're going to cleave off the terminal ends of it. We cleave off some of the ends. We're left with this middle segment. That middle segment is going to be called tropocollagen. So tropocollagen. And from here, we undergo another step, because we all know that simply plain old collagen is what our end goal is. So tropocollagen still has a prefix, and the next step also has a disorder associated with it. We'll cover that at the very end. But right here, what happens is we're going to have cross-linking. This cross-linking is going to be our final step. So what's going to happen is the tropocollagen is going to self-assemble, and it's going to be reinforced with lysine, hydroxylysine covalent bonds. So let me bend down here. Lysine, hydroxylysine, covalent bonds. It's going to give collagen some of its strength. So the tropocollagen is going to form bonds, covalent bonds with itself to strengthen it, and that will give you collagen itself. So tropocollagen is almost the end form, however, we all know that this is the final end product because we don't ever talk about tropocollagen type 1, 2, 3, 4. We talk about collagen type 1, 2, 3, 4. So what we did is we went from pre-pro collagen to pro collagen to tropocollagen to plain old collagen. So the more I look at collagen and say it, the more strange it sounds. So let's stop saying that. Okay, so let's talk about some disorders. The fibroblast disorders. So we all know that fibroblasts make this collagen, and we now have disorders. So let me, I'll get rid of our roadmap, because I don't think we need that anymore. We're already at our destination. I'll get rid of some of this. Just going to try and make it a little more friendly to look at here. I'm going to leave this disease, because that's a disease. And we'll use red. I think red would be an excellent time. All right, so the first disorder is going to be from the conversion of the procollagen into the Golgi apparatus. So if we knock off this step right here, that's going to be osteogenesis imperfecta. So I'm going to osteogenesis imperfecta, I'm going to abbreviate it OI, and the most common form of osteogenesis imperfecta is type 1. So I'm just going to have a little sub 1 here, just so you can understand my shorthand. So we're going to talk about osteogenesis imperfecta type 1. And what it is, it's going to be an autosomal disorder, meaning has a dominant allele. Autosomal disorder, and it's going to affect collagen type 1. So type 1 collagen. What type 1 is, I left that up for a reason. We're going to affect the bones, we're going to affect the tendons, the ligaments, and finally the teeth. So let's piece this together. If we have a type 1 collagen disorder, our bones are not as strong. We're going to have bone defects. We're going to have easy fractures. So we're going to have fractures in this disorder. People with osteoimperfecta type 1 have brittle bones. It's known as brittle bone syndrome, osteogenesis imperfecta. And there are different types. That's why we're talking about type 1. It's going to be the most common. Type 2, typically not really conducive to life. There are instances, however. So let's talk about type 1. Type 1, you're also going to have blue sclera. So the sclera of your eye is typically white. You're going to have blue sclera. And that's a pretty high yield buzzword. If you have a person comes in with multiple fractures or a history of multiple fractures, blue sclera. Ooh, I'm running out. Toss this. Grab another. Oh yeah. Blue sclera. I like how bold that is. That's a good buzzword, so let's make it bold. All right. Then also you've got maybe hearing loss, and this hearing loss will manifest in, it can manifest in childhood, however more commonly it manifests in early adulthood. So I'm just going to write hearing loss. Just know that it can happen mostly in your early adulthood, so anywhere from your teens to 20s is when that's going to happen most often. You should be diagnosed before then. So osteogenesis imperfecta. After glycosylation, we're unable to move it over to the Golgi and mature it beyond that. So let's see, we're not able to create these triple helical units in the end for our type 1 collagen, therefore osteogenesis imperfecta. Let's talk about another clinical aside here. That's going to be Ehlers-Danlos syndrome. You may have seen someone with Ehlers-Danlos syndrome already. Contortionists typically have Ehlers-Danlos syndrome. Also, people with skin disorders where they're able to pull their skin and it comes way up. I don't have it, so I'm kind of glad, actually. Otherwise, you'll see hypermobile joints. So that's Ehlers-Danlos syndrome. And Ehlers-Danlos syndrome is going to be both type 1 and type 3. So what I just described is, I described hypermobile skin, so that's type 3. That's going to be the main portion of Ehlers-Danlos, but it also affects type 1 collagen. So like I said, they'll be hypermobile. That's why a contortionist has Ehlers-Danlos in most cases. They have hypermobile joints. So we all know that joints, bone and bone, muscle and bone. So type 1 collagen is also going to be affected. So where does this Ehlers-Danlos come in? It's going to be with the cross-linking phase. So we're going to have a disorder here. We're going to not be able to bond. We're not going to be able to cross-link the tropocollagen together to form our most mature collagen form. Therefore, just trying to grab a chair here so I don't have to bend down. Ehlers-Danlos. We'll do that. Ehlers-Danlos. If you don't mind me sitting here, Ehlers-Danlos is going to be type 1 and type 3. You're going to have also, so I described skin, I described joints, and then also you're going to have blood vessels that are going to be weaker. So notice over here I was talking about scurvy, you'll have bleeding gums. Down here you might see aneurysms, for example. Aneurysm would be just a weak blood vessel, and so in Ehlers-Danlos syndrome, also you have the joints, you have skin. That's for completeness. So we've talked about scurvy, we've talked about Ehlers-Danlos, we've talked about where's osteogenesis imperfecta, and then the last one that I want to cover, I mentioned at the very beginning, dealt with type 4 collagen. Type 4 collagen, let me get my red out again, and I'm going to write it down here. We're going to talk about Alport syndrome. Alport syndrome, there we go. So what is Alport syndrome? Well, I just said it was type 4 collagen, and we know that type 4 collagen deals with basement membranes. So Alport syndrome is going to be a basement membrane disease, and there's going to be 3 areas of the body that's most going to be affected, primarily with the kidney. The kidney is going to be a big one. Then also you might see stuff in the ear, and then eye defects. So we're going to start with the most important one, the kidney. So the basement membrane of the kidney is going to have type 4 collagen. So in your glomerulus, you're going to have type 4 collagen. And what we're looking at is we're looking at a basket weave pattern, which is going to be more of like a disarray pattern of type 4 collagen within the glomerulus of your kidney. So I'm going to say BM for basement membrane will look like a basket weave appearance. Basket weave appearance. That's kind of just a traditional mark. You'll also see nephritic syndrome, not nephrotic syndrome, which is a different thing. Nephritic. Nephritic. Struggling with spelling today. Nephritic syndrome. So this is also due to that basement membrane problem. So if you think type 4 collagen, first thing that should come to mind is Alport syndrome, your kidney. Also, you may have ear associations with it. You'll get more of a deafness. So, a deafness. And typically you should see this deafness in people less than 30 years old. It's pretty early onset deafness. And then lastly, ocular, kidney is most important. You may have deafness, eye problems. You could have a whole host of problems. Your eye has a basement membrane. It's going to be affected by Alport syndrome because you're not able to synthesize that type 4 collagen correctly. Hopefully this is a good place to stop. Hope you enjoyed the basics now to the synthesis and some of the clinical disorders that can go wrong once we have this collagen created or in the creation process. If you have any questions, be sure to ask. Any comments, please feel free to comment. Please click like if you enjoy this, and also subscribe for more videos. Thank you very much.